So, the topic of today will of course be wait a little bit. There we go. Now the slide rendered. So I'm told you should always have a little bit of AI in every presentation you do. So this was my contribution. So I will be speaking about landing zones, and more specifically about infrastructure and application landing zones on HCP. But before I begin, let me outline a problem. So 97% of organizations are struggling with cloud infrastructure. So let that number sink in for a moment. In my personal experience as a consultant in this space, this number should actually be 100%, right? So this number comes from the 2025 Cloud Complexity Report. It was released just 2 weeks ago. It has many other interesting findings. You can go and read it. So how do we deal with cloud complexity today? Well, one common approach is that we use cloud landing zones. And to understand what I mean by a cloud landing zone, go to your favorite cloud provider and to the documentation and read what this cloud provider thinks about landing zones. Then you get sort of an idea. But generally, it covers sort of fundamental components around your cloud infrastructure in this given provider. So this is about resource management, networking, cost management, etc. So who really benefits from cloud landing zones? Well, I would argue that these cloud landing zones are primarily in the interest of your platform engineers, right? So this is really to put order into what your platform engineers are building and providing to the rest of your organization. Cloud landing zones do fairly little for your individual developer who is then deploying applications to these landing zones. All right, so you have implemented cloud landing zones, and what you're still encountering, even for a single cloud provider, is this proliferation of cloud services. So just take your favorite cloud provider and look through what kind of services they are offering, and you will meet this proliferation of availability. But today's reality is more about, looks something like this. You're using multiple cloud providers, you have your on-premises systems, and what you meet is sort of this explosion of available cloud services right across all of your providers. Yet at the same time, what we are solving using these services can often be described, like in the majority of cases, be described by this simple architecture diagram. You have a front end, you have a back end, and you have some sort of storage solution. Sometimes you don't even have all of these three components. So there seems to be sort of a mismatch between what is offered, these hundreds of services to solve any kind of problem, and what we actually need, like fairly simple architectures. All right, so cloud landing zones are more about the platform engineer, yet the platform engineer encounters this problem when we are speaking about multiple cloud providers, right? And what about the developer's perspective? So imagine that you're this developer, and you're the type of developer that really loves source code. You know, the kind of source code that actually has semicolon at the end of the line, this type of code. And when it comes to things like Terraform and infrastructure provisioning, cloud infrastructure, configuration management, you know, the traditional platform engineering stuff, this developer doesn't really care for these types of tasks. And I know many of these types of developers, and I don't know, probably you do as well. So a developer like this often finds themselves working at an organization that is either like ongoing with a journey to the cloud, or they are just getting started on this journey. And behind a journey like this, of course, we have this team of highly motivated platform engineers. And platform engineers, they really love this type of work. They love infrastructure as code. They love Terraform. They love cloud services, etc. But we have this, the developer often finds themselves lost in a situation like this, right? They want to write source code. They don't want to spend time configuring Terraform and everything that goes with it. All right, so the problem we have to solve here is really cloud complexity at two different levels. we have at the organizational level, which is more in the platform engineer domain, and how we treat multi-cloud and hybrid environments. And we also have cloud complexity at the developer, the individual developer level. All right, before I move on to discuss a solution to this problem, a quick introduction of myself. My name is Mattias Fjellström. I'm a HashiCorp ambassador. I'm a Microsoft MVP. You can find most of what I do online. I publish in the form of blog posts on my semi-popular blog called Mattias.engineer. Or actually, since I'm controlling the narrative here, this is one of the hottest tech blogs of today. So if you haven't checked it out already, please do. I published 2 books. They're available on LeanPub. It's for the Terraform Authoring and Operations Professional Certification. So do check them out if you want to. All right. So let's now turn to discuss a solution to this problem of cloud complexity. And I believe a good solution has 2 important attributes. First of all, it should provide a unified approach to how we manage cloud infrastructure across all of our underlying environments. And it should also provide abstractions that hide away some of the complexity, or even all of the complexity if we can. So a solution to this has a certain number of components, which is sort of make up the building blocks of the unified approach to cloud complexity. First of all, we need infrastructure management. So we need to be able to manage the full life cycle of any type of resource that we are managing in our environment. We need secrets management. So all of our applications and systems require some sort of secrets, often at least. So we need to be able to manage these in a uniform way across any underlying system. We need to connect our applications together and our users to our applications and so on. So we need network connectivity. We need image management. So this is what our applications are built on, and we want to have sort of a unified way to know what our application dependencies consist of. And our applications, of course, need to run somewhere, so we need compute orchestration. So no matter where our applications are running, we should have a unified approach to how we handle compute orchestration. Finally, to truly unify how we manage all of these other components, we need source code management, right? We want to handle everything as code. Don't worry about the color. I just picked the Git orange color. I liked it. All right, so if we rearrange these components a little bit, we come to what I call the infrastructure landing zone. And the infrastructure landing zone is really about enabling any type of cloud project and to make it a reality, right? So it's the basic building blocks where we build anything else that we can dream of. So in the infrastructure landing zone, we take the infrastructure management, the image management, the secrets management, and the network connectivity parts, along with the source code management, where we have the source code that defines all of the components here on the left. So for instance, if we're implementing cloud landing zones, this is where we would start. We would have an infrastructure landing zone where we then build our cloud landing zones in our target systems. All right, so to come to the application landing zone, we need to add the compute orchestration back into this image. So the application landing zone is really all about an application, not surprisingly. So we want to have this sort of landing zone where an application developer can really focus on the application and not the underlying complexity. And to achieve that, we will make one more important distinction here. We will be splitting our infra source code, which is more about managing the different components on the left. And we split that, so we have the app source code on the one hand and the infra source code on the other hand. And the app source code is really, this is the sort of source code with the semicolons at the end. You know, this is where the real problems are getting solved. The cloud complexity is hidden away in the infra source code repository. So this will allow us to sort of hide away the complexity and allow the developers to focus on what they love best. So we sort of have these 2 extremes of landing zones, right? We have the infrastructure landing zone on the one hand, and we have the application landing zone on the other hand. The infrastructure landing zone, more geared toward like any other project you're about to start in the cloud, it mostly will be used by the platform engineers. While we have, on the other hand, the application landing zones, more geared toward your individual developer. But what you can really do is think about this as existing on a sort of a spectrum of different landing zones, where you might have different levels of abstraction. When you go from maybe not so much on the left, but you go to the right, you get more and more abstraction in place. I will focus on the two extremes in this picture, but you can sort of have this in the back of your mind. So can we do this on the HashiCorp Cloud Platform? Well, if we are allowed to add console and Nomad along with the version control system to this, then I believe we can absolutely do it. So turning back again to the infrastructure landing zone, and now expressing this in terms of what you can do on the HashiCorp Cloud Platform. Of course, in the bottom we will have Terraform, so everything will be managed through Terraform. The infrastructure landing zone comes with one or more workspaces, or it may be stacks, on HCP Terraform, and all the changes everything we build inside of this landing zone goes through the bottom layer here. For image management, we are using Packer, and specifically the Packer registry to have this single pane of glass where we're publishing all our builds metadata. So anything we deploy into this landing zone the metadata will be published to the HCP Packer registry. We'll be using Vault for secrets management. So each landing zone comes with a namespace in Vault, pre-configured with whatever secrets engines, auth methods, and policies that we require. And for network connectivity, we have two different components, right? We have console for machine-to-machine access and boundary for human-to-machine access. So the solution comes with a dedicated namespace on console and a project on boundary, and we can also pre-configure these with certain connectivity to different, maybe on-premises system, etc., that we want to be in place. Right. So for the application landing zone, we just add compute orchestration with Nomad to this solution. Once again, each landing zone comes with a namespace on Nomad where the applications will actually run. I want to add two more pieces to this picture. So since we're treating everything as code, and all the changes go through the bottom layer through infrastructure as code with Terraform, we can apply consistent governance across all of our solution by applying policies in the HCP Terraform, right, with the Sentinel, for instance. And another final piece that I believe is very important to remove friction of obtaining access to a landing zone is, of course, self-service with Waypoint. So we want a developer should be able to order a landing zone with a very low friction and be able to modify the landing zone if needed, and everything goes through Waypoint. All right, so taking a look at what the end-to-end flow looks like for the infrastructure landing zone. So the journey will begin in HCP Waypoint. The user who wants to provision the landing zone can browse between available templates, create an instance out of one of these templates. And each application on Waypoint is, of course, backed by a workspace in HCP Terraform, which is connected to this no-code module in the private registry. And the no-code module is really where we define what an infrastructure landing zone means. So what comes out of this is, first of all, we have a Git repository where any change we apply to the infrastructure landing zone will go into this Git repository. And this one is connected to Terraform, a workspace on HCP Terraform that is pre-configured with credentials to work with all of our other target systems, including our console namespace, our Vault namespace, and our project on boundary. So this is sort of it for the infrastructure landing zone. We're just providing the basic building blocks, and then the user of the landing zone will build whatever solution they are building. For the application landing zone, we have sort of a similar approach. We'll once again start in Waypoint. The user will select a template and create an application out of it. Once again, there will be this sort of management workspace on HCP Terraform set up, connected to this no-code module that configures or defines what an application landing zone really is. An important distinction here from the infrastructure landing zone is that all of the pieces that comes out of this provisioning of the landing zone are considered to be managed, in the sense that the end user will never interact with these directly. So these are managed by an underlying platform team. And just to describe how Packer fits into the solution, I mentioned that the only way that the developer will be interacting with the application landing zone is through the application source code repository. So we have that repository here. Whenever a change is committed to this repository, there is a new build kicked off. This build is logged in the metadata is published to the HCP Packer registry, and the artifact is published where it needs to be. Right, once a new artifact is available, this will be picked up by the workspace on HCP Terraform. This workspace will read the latest metadata of the available build and push this out into the Nomad namespace. And once that is done, the application is available for the end user. Right. So if we can switch to the laptop. Here we go. In case somebody who works with the HashiCorp Cloud Platform is available in the audience right now, I think you get signed out pretty aggressively in this portal. Never mind for now. So to show what this experience looks like, well, we can take two routes, like looking at how it's implemented, but that's going to take more than whatever time I have available. So what I want to show here is really the end user experience. So imagine that I'm a developer, and my favorite hobby in the world is writing source code, right? So, and now I want to start working on a new web application, right, for my company. So what it would look like is basically the developer would go into the HashiCorp Cloud Platform and navigate to Waypoint. And now this is going to look like a demo for Waypoint. That's not the point here, but the point is to illustrate the frictionless experience. So I can select my applications, and I see I have a number of applications up and running, but I want to create a new application. And here I select between my available templates. I want to create an application landing zone, and I have to give this a name. So demo app. No, I don't want that. Thank you, Apple. Demo app. Create application. All right, so that was basically it. Now, what is going on in the background, of course, is Terraform is, well, you can see it here in the little square. Terraform is doing something in the background. But what we're giving the user here is just a simple README of how to get started. Your fully managed application landing zone will soon be ready. And what I get here is a link to a repository and a link to a running application. So this will take a few minutes. So I just want to show a different application. So this is another instance of the application landing zone. We see that I can open this Git repository. So I immediately get this sort of base boilerplate application where I can get started. I can copy this git clone command and just immediately go into the source code and start hacking out the details. And I also get like an immediate, the website is immediately available on this. And this is a multi-cloud snake experience. You can actually go to this website if you saw the URL. Let's go back to our demo app and see if it's ready. It's still running. But what I want to convey with this demo is, now it's success. The frictionless experience of getting a very opinionated design of an application landing zone, right? So what the developer now would do, basically open the new Git repository and get started working on this application. And there is no need to understand that the application is currently hosted on Nomad. The namespace in Nomad, it's connected to Vault, it's connected to Console. We have boundary boilerplate projects set up, and we have underlying HCP Terraform workspaces provisioning all of this. So from the end user's perspective, I got an application, I can work on source code, I don't need to care about the underlying complexity. Let's see if our application is actually up and running. Yes, all right. So I get this placeholder web application. And of course, this doesn't have to be a web application, it can be anything, but this is for the demo's purpose, right? All right. So, have we solved cloud complexity? Well, to be fair, cloud complexity is not just a technical problem, right? So if we want to also tackle the other side of the coin, the people problem, I'm going to need more than half an hour to speak about that. So maybe next year. But what we have done is, at the organizational level, we have provided a unified approach to cloud infrastructure management. And this approach reduces tool sprawl and system fragmentation. We do this by standardizing on the set of tools we use, in this case the HashiCorp Cloud Platform, along with Console and Nomad. This leads us to faster time to market, and this is especially true for the application landing zones that we create for our developers, so the developer can focus on what they do best and do not have to care about the underlying cloud complexity. We reduce risk and we build in compliance. Since we're applying all our changes through Terraform using a common approach for all our environments, we can sort of build in compliance from the start, and nothing that is not compliant can make it through this workflow. And of course, self-service improves scalability, right? So our developers can work on their own provisioning landing zones to get started. At the developer level, we have provided infrastructure abstractions and self-service. Abstractions in the case of templates that are very opinionated to how an application should look. And we provide self-service through Waypoint. So this lets developers choose their preferred level of cloud complexity, right? Because as I said, you could offer different types of abstractions. So in the case I showed you, everything was abstracted away. So this leads to improved developer experience. So the developer can really focus on writing source code. That's what developers love to do. Reduces the cognitive load on the developer. It doesn't have to understand what the cloud services are available and which cloud service should I use for this given problem. Now it's more about focusing on the application. And finally, the developer can work with greater autonomy, right? Yes, ordering a landing zone, doesn't need to sit with a platform engineer at his side just to understand what is going on. All right, so if you want to learn more, I have a blog post on this very, very hot technical blog, the hottest of today. So it's available right now. If you scan this QR code, or if you go to this link, or just go to mattias.engineer and you will find it. So thank you.